Well, hello everybody. Welcome back to this live office hour on Trig and Pre-Calculus, and this is brought to you by Chegg. My name is Blackpen Repen, well, as you guys know me, and if you guys are from the Chegg's social media, then welcome. Nice to meet you guys. And I've been a math YouTuber, I guess, for like the last decade, a long time. And I also have been a math teacher at community college for over a decade, so also a long time. For the people who were here last week, thank you guys so much. Welcome back again. And if this is the first time that you are here, well, you can just think about this as like an online office hour. The goal for today is to help you understand more about trig and pre-calc. So if you have any questions regarding trig and pre-calc, feel free to drop it in the chat. I will try my best to answer them all. And let's go ahead and get started. I have my first question, similar to last time. All right. So hello, everybody. We are going to get started. All right. Which of the following is true? If you were here last week, you know we went over a very similar question by the end of the live stream last time, right? So here, A, I have the arc sine of the regular sine of 2 pi over 3 is equal to 2 pi over 3. And then we also have the inverse cosine and cosine, inverse tangent and tangent, and they are all 2 pi over 3. So which one of this is true? Please go ahead and drop your answer in the chat. Let me know what you guys think is. And maybe they are all true. I don't know yet. You guys let me know, right? So, hello everybody. I'm going to say hi to the people in the chat. Thank you guys so much for coming back, or if this is the first time that you're here, welcome. This live office hour is brought to you by Chegg. You can scan the QR code over there. Right? You can check out more of the Chegg social media. All right, so I'll give you guys another 20 seconds. Yeah. Okay, a lot of you guys are saying B, but also some of you guys are saying D over above because it's like inverse, original, inverse, original, inverse, original. This should just all be 2 pi over 3, right? Yes, I see a comment in the chat. You have a very good point. You said you don't, hold on, quite remember the domain for these functions. Well, that's what I'm going to review for you because we do have to pay attention to the domain for the functions right here to have inverse. All right. So I'll tell you the answer is D. No, just kidding. Answer is B. Answer is B. Answer is B. So if you got it right, yay. Now let's take a look at why this is true. So here's the deal. If we have the inverse sine of the original sine of, let's say, x, this is equal to x on the condition that you have to focus on where the sine function has its inverse. And the way that we define it is we go from negative pi over 2 to pi over 2. So this is only true if we are talking about the interval. Let me write it like this. Hopefully, I should have enough space. Pi over 2 to positive pi over 2. Right? Can we see this okay? Let me kind of erase this a little bit. I'll just put on the if right here. There you go. Much better. So as you can see, 2 pi over 3 is actually not inside of this interval. Therefore, this is incorrect. By the way, for bonus, go ahead, please compute this for us. What's the inverse sine of original sine of 2 pi over 3? This is not 2 pi over 3. So go ahead, leave in the chat. Now I will continue explain the second one. When we have the cosine version, inverse cosine of original cosine of x, this is equal to x if x is in between of 0 and pi, including the endpoints. Now, as you can see, 2 pi over 3 is really inside of this interval. Therefore, this right here is legitimate. This right here is correct. Now, this is the one that we did last time. When we have the tangent version, if we have the inverse tangent of the original tangent of x, you get x under the condition that x is in between of negative pi over 2 and pi over 2. Do we have equal signs here? Do we have equal signs there? No, right? No, because remember, tangent of pi over 2 is not defined. So this and that, the difference is just that we include the endpoints here, but for this one, we don't. And perhaps let me just write it down better for you guys. This is negative pi over 2. Okay? So in my opinion, this is one of like the trickiest question in your pre-calculus class or trig. Yeah. Did anybody get this? All right, I think I see an answer. Did anybody get this? What's the answer for this one, for the first one? It's not 2 pi over 3. What's the correct answer for this? This is live. Yeah, this is live. This is live. You can just think about this as like a live office hour, online office hour, and it's brought to you by Chegg. And definitely check out scan the QR code over there so you can check out more information about Chegg. Yeah, especially if you need help with like math or any of this study, they have experts and tutors you can check out. So go ahead and click on that. The first one is not 2 pi over 3. Yes. I'm just going to write down the answer. The first one, I believe, yes, you guys are right, pi over 3. How about C? How about C? Again, this right here. You have to think about it. And the way you do it is you do it inside out. And then the final result, you have to think about the output, which is the range of the inverse tangent. This is also not correct. So some of you guys are saying pi over 3 or 2 pi over 3. Yes, sine of 120 degrees will turn into sine of 60, and then you can cancel them out. You're right. So you can do the same thing for this one right here. You can do the same thing for this one right here. All right. So I'm gonna leave that to you guys for you guys to figure out. All right. So now it's your time. If you have any questions in your trig class or pre-calculus class, go ahead, put it in the chat. I'll try my best to answer it. In the meantime, I'm going to erase the board. So how are you guys doing? How are you guys doing this evening? Right now is 6:53 p.m. Pacific time, and we will be going live this time. Last time we had it from 6:45 to 7:45. Today we will have the same. Right, the live will be going for an hour, and this live is brought to you by Chegg. And now, please go ahead. If you have any questions, let me know. If not, I'm going to ask you guys another question. Earlier, the answer was B. Right? The answer was B. So now, please, if you have any questions, you can go ahead and leave in the chat. In the meantime, I think I'm just going to give you guys another one for this one. I think it's going to be slightly, well, more standard. It's not that tricky anymore. Yeah, so let's talk about if you have cosecant square x plus secant square x. We would like to know what this is equal to. And then I am going to give you guys choices. A, 1, B, not 1, tangent square x. C, sine square x times cosine square x. And then D, cosecant square x times secant square x. All right, so I did prepare a few questions for you with you guys. But if you have any questions, please leave it in the chat and let me know. And please keep them trig related and pre-calculus related. And for pre-calculus, it's just like you can think about it as like the harder version of algebra and also the harder version of trig, because trig is usually a separate class. At least at my school, what we used to, we have a trig class and then later on pre-calculus class, like that. Just leave your question in the chat. Just type your question in the chat. Okay, in the meantime, please answer the question. Cosecant square x plus secant square x is equal to which one? This is a multiplication. Sorry, this is an addition. Yeah, this one looks kind of a little bit strange if you see the answer compared to the original question, right? So I'll give you guys 10 more seconds. Let me know. I'm watching who is getting this right. Right? I'm looking at the chart right over here, so I can see who is getting it right. All right, so A, B, C, or D. All right, final 3 seconds. The answer is D. All right. Now, have a look. This right here is very different than, well, I shouldn't say different. This right here looks very similar to the original question, right? Why? Originally, it was a plus. The answer is a multiplication. And I think this is really cool. And now let's see how we can go from here to here. So the first thing is cosecant. You have to know that 1 over sine, right? So change this to 1 over sine square x. Then we'll change secant square to what? Secant is 1 over cosine. So secant square is 1 over cosine squared. Okay, now we have two fractions. Let's get the common denominator and then combine the fractions. And the common denominator is I will have to multiply by cosine square here and also here. And also we need that right here. So sine square x and then multiply by sine square x. So together, the denominator is this and that. And you can just write it down one time. And then for the top, we have cosine square x plus this right here is sine square x. Now, what can we do though? Because this, I don't see the answer. What can we do next? So what can we do next for this? All right. The top, cosine square x plus sine square x. This, it's a very nice result. Yes, thank you. It's just 1. You don't want to split the fractions anymore. You don't want to do anything. This right here, you have to use the identity, the Pythagorean identity. Yes, I see many of you guys are getting this. Maybe there's a small lag because I see lots of you guys are answering the question now. But yeah. Anyways, here we are looking at 1 over sine square x times cosine square x. And now this is super cool. The answer is not C because both this and that are on the bottom. So this turns into cosecant square x, right? Goes back to cosecant square x. 1 over cosine square turns back into secant square x. That said, we are done, and the answer is D. Just like that. All right. So for the people who just joined our live stream, thank you guys so much for coming back. My name is Blackpen Repan, as you guys know. If you are from the Chegg social media, if this is the first time we meet, welcome. Nice to meet you guys. This is the virtual office hour hosted by Chegg, and today we're talking about trig and pre-calc. And now, if you have any questions, you can drop in the chat, and I will try my best to answer them all. So go ahead and do just that, and I will be erasing the board. So right now it's 7 p.m. Pacific time. Next week, we will also have the live office hour. And if you need help with calculus, check out Chegg. Check out their social media. They have live office hour for pre-calculus, calculus, and also other subjects as well. Chemistry, general chemistry. Go ahead and check them out. Okay, so I have a question regarding general formula for trig shift. Do you have a specific question though? Or I can review it with you real quick. So if you have y, it's equal to, here is the standard form. It depends on which form that you use in your textbook also. If you have a times sine of bx plus c and then plus d. So this is one standard form. Some textbooks, they may factor out the b right here, right? So just keep that in mind a little bit. I'm going to just use this right here. And also, if we have y equals, you can talk about the shift and also the amplitude and all that with sine and cosine. So a times, we did the sine already, cosine, and then bx plus c plus d. So these are the forms. Now, here are the things that you have to know. What the a tells us about the graphs of the this and that function. Okay, so the amplitude. I think I spelled it right, hopefully. Today I have a horrible time spelling in my pre-calculus class, like about 5 hours ago. Yeah, I actually teach as well. So yeah, anyways, amplitude. I hope this is right. It's not just A though. It's the absolute value of A, right? It's the absolute value of A, okay? And then the next thing that you will need to know is the period. So I'll just spell this out. I really cannot spell today. All right, for period, you have to look at the number b, right? The coefficient b. You do 2 pi over b, right? 2 pi over b. And technically right here, we should have denote that b should be positive. Right? B should be positive in order to let this work. And if it's not positive, if you have, let's say, negative 2x or whatever, you can factor out negative. So that's okay. Yeah. Let me see. Okay. Let me see. All right. So we can talk about how to graph it later on, but amplitude and then also the period. And next, we have the phase shift. And the word phase shift, you can just think about it as the horizontal shift. All right. And for this one, pay close attention to it. Some book will just say this right here is equal to negative, right? The opposite of whatever you see right here. Negative C over B. Negative C over B. If it's a positive result, right? If it's a positive result, it depends on how they want you to answer it. Depends on the textbook. Sometimes they will say to the right, however many units, or to the left, however many units. So I really cannot just answer that without like using the word to the right or to the left. But this is usually how you can just like plug in and work out, I'll say. Okay, and then lastly, of course, we also have the vertical shift. And that is just the number D. If D is positive, that means you shift up. If D is negative, you shift down. So these are the 4 main things that you will need to know. Right? These are the 4 main things that you will need to know. 2 pi divided by the absolute value of b. Correct. Here I'm saying b is positive, so it's positive right here. It really depends on how your textbook presents the formulas. Yeah, so if you don't have this condition, I will agree that you put the absolute value around here. So that's just like a tiny detail or kind of technical part that you have to be careful. So hopefully this right here helps. Right? Hopefully this right here helps. How to derive the double angle formulas? Double angle formulas. Okay, let's do that real quick. Last time we did the half angle formula. Today we'll do a double angle formula. So that's nice. Okay, have a look. Let's do both sine and cosine because they are not so bad. I would say they don't take too long. So here the question is, how do we do the sine and cosine of 2 theta? Right? So in order to answer this question, here is what we will have to know. In fact, let me just write down the note right here for you guys first. Note, if we have sine of two things adding, let me just use A plus B. So we have two angles. This right here, you can break it apart. The angle sum formula for sine is sine of the first times cosine of the second, and then plus, and here it depends on how your textbook writes it. You can also write sine of second times cosine of the first. Some textbooks, they write cosine of the first times sine of the second. So they might switch this, but either way, it's okay, of course. And if you have the cosine version, A plus B, this right here is a little bit trickier. We are going to get cosine A times cosine B. Now, be careful. For the cosine version, if this is a plus, in between here, it's actually a minus. It's actually a minus. And then we will have sine A, then sine B. Right? So for this right here, you can draw some diagrams to prove it. Maybe we can do that next time because I want to answer the double angle identity first. So right here, for the double angle identity, if you want to figure out sine of 2 theta, this is what we can do. Look at the 2 theta as theta plus theta. And guess what? This is like the A, this is like the B. So we will end up with sine of the first, cosine of the second, plus sine of the second, which also happens to be theta, and then times cosine of the first. And now you see sine theta, cosine theta, sine theta, cosine theta. We have two of them. And there you have it, 2 sine theta, cosine theta. Similarly, you can do the same thing for cosine 2 theta. All right? So you can go ahead and give that a try. Do the same thing, cosine of theta plus theta, and use this identity, and then you will be able to get the double angle identity for that. Okay, let me... Can you give a graph from which we can find from its trig function? So Matt, you are asking how to graph a trig function. Can you give a graph? Yeah, is that the question? How we can graph a trig function? So you can let me know, or if you have a specific question, if you guys have specific question, that would be really helpful. So that way I can just like try my best to answer them for you. If you have a general question, sometimes the topic is broad, so it might be hard for me to answer what you need to know. So yeah. All right, so if you have questions, please go ahead and leave it in the chat. If not, I have another fun one for you guys. This one might shock you. All right, so this is the question that I have for you guys. So I have tangent of x, and then we are going to add tangent of y, and we will let you know this is equal to what? Okay, option A, tangent of x plus y. Option B, we have sine of x plus y over sine of x, sine of y, and then c cosine of x plus y, and then sine of x cosine of y, and then d. I have sine of x plus y over cosine x cosine y, cosine x cosine y. Yeah, this is great because we just went over the angle sum formula, but this time you have to be careful. We have tangent, but x and y is different. Yeah, it's not x plus y for tangent. It's tangent x plus tangent y. I think this is a really fun one. So go ahead, let me know what the answer is. Drop your answer in the chat. And for the people just coming, thank you guys so much for coming in here. Welcome to the live office hour brought to you by Chegg. And check out the QR code over there. If you are taking other classes, if you need help with any other subject, including chemistry, physics, go check them out. They also have like calculus office hours on Thursday, I believe. So make sure you stay tuned, subscribe to their YouTube channel, and follow their social media so you can also join their live office hours. But today, right here, we're doing trig and pre-calc. Okay, so please go ahead. We have A, B, C, or D. All right, I'm looking at who is answering the question over there. And by the way, what time is it over there? Where you are from? Right now it's 7 p.m., 7:12 p.m. in the evening. So just like last time, I am a little bit tired because I taught in the afternoon. So yeah. But don't worry, I will give you guys my best energy for the rest of the office hour. What do you guys have? Okay, I can explain how to graph cosecant and secant, sure. And I would like to do this right here first. So, Evan, I'm going to answer your question after this. For this one, the answer is, I know I like to put option D. This one's kind of special because, of course, definitely don't say A, right? Definitely don't say A. Yeah. Oh, some people maybe are from East Coast, so we are like 10, 13 p.m. Cool. All right. All right. So just real quick, tangent. Let's just do the usual business. That's the usual strategy. Change tangent x to sine x over cosine x. And then we add tangent y, that's tangent, of course. That's sine y over cosine y. Now, get the common denominator, just like the example that we did not long ago. And then right here, we multiply by cosine, because we need this, cosine x and also cosine x. Now, as you can see, they have the same denominator. So we can just go ahead and put down cosine x, cosine y one time. And then here we have sine x times cosine y. And then we add sine y times cosine x. And do you guys recognize what this formula is? Sine of the first times cosine of the second plus sine of the second times cosine of the first. This is just the angle sum identity for sine. So we get sine of x plus y. And this right here is inside of the sine function. And then after that, we divide it by cosine x times cosine y, which is equal to that. And then we are done. Okay, and then I'm going to show you guys how to graph the how to graph the cosecant and also the secant function. So here, let me just go ahead and write y is equal to cosecant x. So I'm going to get the graph right here in red, okay? And this is how you can make a quick sketch. Just a quick sketch, like seriously. In order to graph cosecant x, if you want to make a quick sketch, you will have to remember the graph word sine, right? So note that cosecant x is equal to 1 over sine x. So they are, of course, related. I will show you. Let's graph the sine function first. Starting at 0, 0, and then we go to pi, and then 2 pi, and so on. And then let's also go to the other way. This is negative pi, and then we also have negative 2 pi. And remember the range for sine, it goes from negative 1 to 1. So I will say here is negative 1, and here is positive 1. Now, starting at 0, 0, and then we go up to pi over 2, and it's going to be 1. And then it's like this. So go up, come back down, like this. And then you go the other way. Like that. Just a quick sketch. Hopefully my picture looks okay. Now, this is how we are going to get the cosecant graph. And this is the key. So, you go to the zeros on the sine function. So as you can see, for example here, at pi, the one in black is the sine function. Sine of pi is 0. Remember, cosecant is 1 over sine. So if we have 1 over 0, that's undefined. And in this case, we'll actually get a vertical asymptote at pi. So let's go ahead and indicate that. I'll indicate this in blue. So wherever you see the 0, just go ahead and draw a bunch of the vertical dashed lines. And then like this. And of course, the graph keeps on going forever. And of course, there's no way for me to keep on going forever either. Now, here's the best part. You ready? This right here is 1 for sine. If you have sine of an angle, in this case, pi over 2, is 1. 1 over 1 is still 1. So, the cosecant function is going to touch this point. Likewise, 1 over negative 1, the cosecant will also touch this point. So, similarly, the cosecant graph will all touch this point. Now, you're just going to get a lot of U shapes opening up and also opening down. You can just make a quick sketch like this. And make sure the curves gets really close to the vertical asymptotes, but just think about them as like boundaries. You do not want to cross them over. No. So it's like this, and then like this, and then like this, and then like this. Okay. So ladies and gentlemen, the one in red is the cosecant function. And you can do the same thing for cosine, right? You first graph cosine, and then you do 1 over cosine, then you get to secant. So I will leave that to you. Okay, so now let me know if you guys have any questions. I see lots of chats, so I'm going to see. And make sure your questions are like in trig and pre-calc, and then keep them with like textbook level. So like a standard, more like a standard questions. Because our goal is to help you get better at your trig and pre-calculus class. Let's see. When you look at a trig function, what does it do geometrically? When you look at a trig function, what does it do geometrically? I'm not sure what you mean by it. What do you mean the it? You mean the function geometrically? Or are you talking about like the unit circle matching to the sine and cosine graph? Then in that case, it might be hard for me to demonstrate. I will try my best. So here, this is the unit circle. Right? This is the unit circle. And then what we are going to do is we're going to run around the unit circle. In the meantime, we'll keep track of the x and also the cosine value, the x and also the y value. So remember, this right here is cosine theta, and then the y value is sine theta. So this is the angle theta. So what's happening is that you can see starting at this point when angle theta is 0. So I will do this for you. Let's talk about cosine, because earlier we didn't do cosine. So have a look. When we start right here, when theta is equal to 0, the x value at this point is equal to 1. So we go to 1. So that's our first point. And now if we rotate, as you can see, the x value is getting smaller and smaller, right? Because originally it's like this, which is 1, and then it's going to be smaller, and then 1/2, and then less than 1/2, and then get to 0. When does it get to 0? When theta is pi over 2. So we get to pi over 2 right here. And then you will see that the curve will look like this. Yeah, that's for cosine. And then what's happening is that if you keep rotating, you can see that the y value, the x value, you become negative. And then getting bigger in terms of the absolute value. It's like more negative, right? It's getting toward -1. So like that. So it's going to be, when you get up to pi, you get to -1. And then again, you keep track, and then this is going to give you like smaller x value in terms of the absolute value, right? The size wise. So you will go back to 0, and you hit 0 at this angle, which is 3 pi over 2. And finally, when you rotate here, you can see even though we're down here, but the x value is positive since it's on the right hand side of the plane, right? So it's going to go back up. And then we get to 2 pi, like this. Okay. Yeah, hopefully my picture looks okay. But yeah, that's it. What's the most common type of pre-calc homework in textbooks? I would just say like solving polynomial equations, solving anything regarding trig, right? Those are the standard. And then exponential equations, logarithmic equations, and all that. Can you explain trig limits from left and right? Is there any rules? That's more like calculus, and I will recommend you to come back on Thursday for their pre-calculus office hours. Okay, let me just like take a look. Let me see. Okay, I think this is the type of questions that you definitely have to do for pre-calc and trig. How do we find sine of 15 degrees? And you mentioned that there are 2 ways. Yes, and both ways are okay. So depending on either the direction, if there's no direction, whichever way to use, it's okay. So let's just take a look real quick. Let's figure out sine of 15 degrees. sine of 15 degrees. The first way is that we can use this formula because you can think about, I don't know about 15 degrees, but we do know 45 degrees and 30 degrees because they are the special angles. So we can look at this as sine of 45 degrees minus 30 degrees. Okay, this right here is a difference. So we'll just use the angle difference formula for sine. And for this case, I'll just tell you we get sine of the first angle times cosine of the second angle. And for the sine version, if this is a minus, you will get a minus here. And then we do sine of the second angle times cosine of the first. Even though we made the question longer, but the thing is that we know how to do this, and that. So we know everything. So that's great. Now, just real quick, let's go ahead and review the special right triangles. We have two of them. This right here is a 45, 45, 90 special right triangle, 1 square root of 2. And the other one is a 30, 60, 90 special right triangle. So here is 30 degrees, 1, and then 2 square root of 3. And this right here is a 60 degrees, but we don't need that. Now, by looking at this triangle, sine of 45 degrees is 1 over square root of 2. And then cosine of 30 degrees, look at this triangle. Cosine is adjacent over hypotenuse, so square root of 3 over 2. And then continue, minus sine of 30 degrees, so that's 1 over 2. Cosine of 45 degrees is this 1 over square root of 2. Just like this. Now, they have the same denominator already, so I'm just going to write them as a big fraction. Put the 2 first, and then we have the square root of 2. For the first one, 1 times square root of 3 is square root of 3. For the second one, it's just minus 1. Okay, here's the usual direction. Square root of 2 on the bottom, no good. Rationalize it by multiplying square root of 2 on the top and square root of 2 on the top. On the top and bottom. Be careful though, it has 2 terms here, so make sure you put parentheses. Now, this right here, 2 times 2 is 4 in the square root. You get just regular 2. So, on the bottom, you really just have a regular 4. And then distribute this. You can multiply the insides together. You get square root of 6. This times that is minus square root of 2. And then we got that. Okay, the other way to do it is that, let me see if I can fit in here. The other way to do it is we can look at sine of 15 degrees as sine of 30 degrees over 2. And then from here, we'll just use the half angle identity. Now, for the half angle identity, it's a plus or minus square root of 1 minus cosine of whatever this angle is, which is 30 degrees, and then over 2. And then you have to think about, do we take the plus or the minus? The answer is the plus, because sine of 15 degrees is positive. This right here has to be positive. Sine of 15 degrees is in the first quadrant, so positive. And then you just pretty much work this out. Big square root, 1 minus, this is square root of 3 over 2. And then all over 2 again. And then by looking at this, we can multiply the top and bottom by 2. So that way we can get rid of the compound fraction inside. So now square root, this times this is 2, this times that they cancel, so minus square root of 3, over this times this is just a 4. So this right here will do it. They look very different, right? But I will tell you, if you use a calculator, punch this into the calculator and do the same here, you will get the same answer. Can you show it, Joe? Can you show this algebraically? Yes, but it will take some time, but maybe you can do that in the future. Yeah, but I think if you see that they have the same decimal values, then of course they are equal. So hopefully this right here helps. All right. Now for the people who are here, thank you guys so much for coming. And for the people who just came into a live stream, welcome, welcome, welcome. Thank you, thank you, thank you. All right, so today our goal is to talk about trig and pre-calc, and this live stream is hosted by Chegg. So go ahead and check out their social media by scanning the QR code. And if you are taking calculus, you can come back here on Thursday for their calculus online office hour. Okay. Let me see. We can do a cosine of 3x real quick, right? Let's do a cosine of 3x. That's a triple angle identity. Because I figure if we did a double angle, let's just do the triple angle real quick. So cosine of 3x. And let's do this real quick. So very straightforward. This right here, you write it as cosine of, let's say 2x plus x. And then we use the angle sum identity from what we talked about earlier. So this, we will have cosine of the first times cosine of the second. And remember, here it's a minus. If it's an angle sum for cosine, here it's a minus. And then you do sine of the first times sine of the second. Usually, when we want to get an identity, we want to keep it in terms of just a single angle, just an x inside. That means we don't want this, we don't want that. So here we go. Let's go ahead and change it. Which one can we use though for this one? Help me out a little bit. Let me see in the chat. Help me out a little bit. Right here. Which identity can we use though? Because there are 3 of them, right? The double angle identity for cosine. Which one can we use? Help me out in the chat. Okay, give you guys like 20 more seconds. Which one are we going to use? Because for this one, it's like the standard one, right? Okay, I will try to solve that later on. Sine of x is equal to 1/2. Okay, yes, this one, good choice. Let's put 2 and then cosine square x minus 1. Because if you start with cosine, we'll try to deal with everything in terms of cosine. That's a great idea. Remember, there are 3 choices. This is the one that you can try to use. But for this, it's just one of them, right? 2 sine x times cosine x. And then here we have one more. Now, distribute. So 2 cosine third power x minus cosine x. Here though, be careful. We have sine x times sine x. So let me write down the minus 2, and then this is cosine x. But here we have the sine square x. If I want to write everything in terms of cosine x, what do we do with this? What do we do with this? I want to write everything in terms of cosine x. Then what do we do with this? This right here is the Pythagorean identity. 1 minus cosine square x. Why do we do this though? Because next we can distribute, right? So let me just write this down again. 2 cosine 3x minus cosine x. Negative 2 cosine x times this is negative 2 cosine x. Negative times negative, be careful, it becomes a plus 2. And then cosine x, cosine squared. This is cosine squared. So here we have cosine third power x. Aha, I think we have the formula. This and this can be combined, and that will give us 4 cosine third power x. Moreover, this and that, we can say that's -3 cosine x. And then we're done. Yeah, we're done for that. Okay. I think there's a second part of the question, but I have to just go back to find it. All right, so for the second part of the question, let me just talk about. I need to stop the scroll. Okay. All right, for the second part of the question, you're going to utilize this right here. I will give you a little hint and you can think about it. You have to think about cosine of what will satisfy that equation. And I think it's 1/2. You're pretty much solving cosine of some angle is equal to 1/2. Yeah, so was, hold on. The cubic equation, I just can't find it because once I scroll it down and then like, hold on one sec. Okay. So you have the 8, you have the 6. So that's the hint. So go ahead and give that a try. Go ahead and give that a try because I think this is the main part. Yeah, this is the main part. So go ahead and give that a try. And I'm going to solve the other quick question right here. Okay, so here we are going to just solve sine x equals 1/2. And we want x to be in between of 0 and 2 pi. So this is how you can do it. Either you think about the unit circle, or you draw the unit circle, or you use the reference triangle method. I prefer to use the reference triangle method, so this is how. Firstly, the sine x part is isolated, so that means we have y over r. So what that means is the following. Have a look. If I look at this, take 1 for the y, I will put it right here. This is 1. And r is the distance between here to here, which is 2. Now, if you look at this, you should remember the special triangle. This right here is 30 degrees, which is pi over 6. So that's the first answer. But in fact, this is y is equal to 1. There's another place that y can also be equal to 1. So you will have to think about all the possibilities. I can go to the other side for the same y value. So I'll put it right here, and then I'll put it right here. That will still be 1 over 2, right? Now, be careful with this though. This angle is still 30 degrees, which is pi over 6. But to answer this question, we will have to measure the angle from the positive x-axis all the way to the terminal side here. All the way to here is pi, but I am missing that part. So what do we do? This angle is just pi minus pi over 6. Now, get the common denominator. That is multiply this by 6 and 6. 6 pi minus pi is 5 pi. And then the bottom is still a 6. So the answers are x equals pi over 6 from here. And then the other answer is 5 pi over 6 from here. Okay. And some of you guys may also think about, we can use the identity and all that. I can leave that to you guys. Sine of 36 degrees, that will take a while. You can use a very special triangle to do it though. The 1872 90 special triangle. It's like a golden triangle. Okay. All right, we have about like 5 more minutes. So let me see if you guys have any other questions that I can answer for you guys. So for the people who are here, thank you guys so much for watching. And make sure you guys scan the QR code to check out Chegg. We have lots of online office hours coming this week. It's brought to you by Chegg. So let me see. Tangent A plus B formula. This right here. Okay, I will tell you how to graph that real quick. So if you have this, right? The graph, it's a little bit kind of funny. It's like this. Yeah, because by the way, this is not perfect graph, of course. This is X, and then this right here is just an up and down. So you are kind of like going along the X. That's how I look at it. So you can just make a quick graph on that. Use a graphing calculator to see a better picture though, or make a table. And then, yes, and then I was saying that tangent A plus B, let's see if we can do it real quick. Tangent A plus B. The key to do this is you look at this as sine of A plus B over cosine of A plus B. And then the top, per our discussion earlier, sine A cosine B plus sine B cosine A. And then I'm going to leave a space. I will say over cosine A cosine B minus, this is a minus, sine A sine B. Why did I say minus? Because of the following. I mean, why did I leave a space? Because of this. Check this out. I'm going to get the tangent A first. To do so, I will divide this by cosine A and also cosine B. I'm just going to divide everything by cosine A cosine B. Divide this by cosine A cosine B, which is this term. Divide this by cosine A cosine B. And voila, you have it. Firstly, this and that cancel. This right here is just tangent A. And then we add this right here. Cosine A cancel. So that's sine B over cosine B, that's tangent B. Over, they cancel, we just have 1. It's a minus. This over there is tangent A. This over there is tangent B. Just like that. So the key is you write it down twice and you divide this term. Okay, so today we have done a lot of questions. Hopefully this right here helps. And then I just want to say a few things. That you guys are awesome. Thank you guys so much for your questions. And this live stream hopefully is beneficial to you guys. Yeah, and let me just make sure you guys have other things. I just want to take a huge thank you to you guys for coming to here today. Yeah, after teaching like in the afternoon right now, doing the online teaching, right, to you guys, it's really, really cool. And if you guys have like, okay, 1 + 1 is equal to, I don't know how to prove that actually. You have to do like set zero or that. But before we go, I just want to tell you, don't forget to check out Chegg.com if you haven't done so already. We are here to support you all semester long, right? All semester long. And we have 24/7 support for your tough subjects. Math, chemistry, physics, you can go check out what they have offer. Check out the QR code over there and see what we can do for you. So make sure to follow Chegg here on TikTok, Instagram, Twitch, and of course YouTube. And for more content like this, make sure you just subscribe to YouTube, of course. And remember, we are here every week. Until then, I wish you guys have a great evening and all that good stuff. And thank you, Rob. Let me see. Thank you, everybody, for coming up.